Hey everyone, welcome back to our AZ-104 certification series. Have you ever wondered how large-scale applications handle millions of user requests without breaking a sweat? The secret lies in a powerful tool called Azure Load Balancer. Stick around and you'll learn everything you need to know about both public and internal load balancers to ace your AZ-104 exam. What is Azure Load Balancer? Azure Load Balancer is a layer 4 load balancer that distributes incoming network traffic across multiple servers, ensuring no single server becomes overwhelmed. Today, we are diving into two types of Azure Load Balancers, public and internal. We'll cover how they work, when to use them, and we'll even walk through some real life scenarios to make sure you're ready for your exam and practical implementation. Now, let's dive into the specifics of load balancer. Let's quickly review what we mean by layer 4 and layer 7 load balancing. Yeah. So layer 4 load balancing works at transport layer, which means it makes routing decisions based on IP addresses and TCP UDP ports. Azure Load Balancer is an example of layer 4 load balancer. It's fast and efficient, but it doesn't inspect the contents of the packets. And layer 7 load balancer works at application layer. It makes routing decisions based on the content of the HTTP headers, cookies, and even the message content. Azure Application Gateway is a level layer 7 load balancer, ideal for more complex routing scenarios like web application firewalls and SSL termination. We'll delve into that in the upcoming chapters when we go through the application gateway. Now, what is an Azure Load Balancer? At its core, an Azure Load Balancer is a high availability and network performance improvement service. It helps distribute incoming traffic evenly across healthy virtual machines. There are two types of Azure Load Balancers: public load balancer, which handles the traffic from the internet, and internal load balancer, which manages traffic within a virtual network. Let's understand the public load balancer. All right, let's start with public load balancer on the whiteboard. Imagine we have a web application that needs to handle traffic from users worldwide. So, so let's assume this is the internet, and then we have a web application hosted on this DNS web.com, and the traffic is hitting this domain name. All right, and this is linked to a public load balancer. We have already seen how do we configure a VM. I mean, basically a public IP address for the domain name using, a record and CNAME record. Similarly, this time we'll be using public load balancers IP address. So this is the public load balancer, right? And at the back end, we will be having multiple, VMs serving the same, web application. This way, the traffic is balanced between three of them so that none of which become overwhelmed. And as the traffic increases, the load balancer will automatically add one more VM to serve the traffic, and if the traffic decreases, it may delete these VMs to save costs. Now let's go to the demo part. So in the demo, we will basically you know create the VMs. In this demo, I'll be creating two VMs in the same region in the same virtual network, and installing Nginx, and I'll be writing this is VM A and this is VM B in the HTML page. And once this is done, I'll be back because we have already seen how do we do that. Now we have deployed both the VMs in the same VNet, and we have installed Nginx in the Ubuntu machine, and we have written a basic HTML stating this is VM A and this is VM B, and these are the IP addresses of both of them. And if you can see, this is routing to this is VMA web page, and this is for the VMB. And if you take a look at the virtual machines, we have two of them. Both of them are part of the same virtual network, that is VMA VNet. Yeah, VMA VNet, and this one as well, the VMA VNet. Now let's try to create a public load balancer. So for that, you can either search over here for load balancer, or you can search in the marketplace. And yeah, so let's create one. Let's pick the same virtual network, same resource group, and let's name it LB Web. And yeah, there are three SKUs: basic and standard art for load balancers. I mean, to balance any internet traffic. Gateway is something that is related to gateway, and it's mostly like out of scope of this course. And then there are two types, as we discussed, public and internal. For now, we'll stick to public. And when it's come to public, there are two tiers, regional and global. What does it mean by regional is, it only manages the traffic that is coming into a region. That is, if you choose east US, then the traffic, I mean, the backend pool has to reside in this one. And if you choose global, that means cross region load balancing is also supported, but it is a little bit more expensive. And yeah, the standard one, I mean the basic one, it's retiring soon, so let's not go into that. And then this is the front end IP configuration. That is, a public IP will be listening to the incoming requests. So let's just create one. Let's call it front end IP. Let's create one as well. Let's call it IPLB, and it has to be static because of the you know skew of the load balancer, which is standard. If it is basic, we can choose dynamic, and this could be basic. So yeah, I'll leave this as it is. And yeah, there's nothing over here. Gateway load balancer, we don't have that. And let's go to backend pools. Yeah, and one more thing is, when it comes to backend pool, you can only use one VNet virtual machines. That is, all the virtual machines of the backend has to be from the same virtual network. So this is how, I mean, you cannot change the virtual network once it is created. You just, I mean, you cannot edit this later. Let's give this backend pool, and yeah, let's add the resources. We have two VMs deployed, so let's select both of them, and let's save this. And next, inbound rules. Let's add a load balancing rule. I mean, how shall the traffic be distributed? Right, let's give LB rule. And IP version, we are using IPv4. Front end IP address, the one which we have created. Backend pool, the one which we have created earlier. Protocol, there are two protocols, TCP and UDP. We'll stick to TCP. And then port, the external, the front end IP will be listening on 80, and backend as well will be listening on 80. I mean, the traffic would be forwarded on port number 80. And we need to create a health probe, that is, that will check for the health of the backend, and if it is healthy, only then the traffic would be routed. So let's create one. Outbound SNAT, we do not need this because this is used by the VMs to communicate to the internet. So yeah, inbound NAT rule. Inbound NAT rule is, whenever the VMs do not have the public IP address, you cannot SSH into it. But using this inbound NAT rules, you can basically use the IP address of load balancer and SSH into the concerned VMs. We do not need any outbound rules, so we can ignore them. Let's review and create. This shouldn't take much time. Let's see, the backend pools. We have both VMA and VMB. In front-end IP configuration, we have this IP address. So let's just copy that. And load balancing rules, we have configured it, TCP/80 backend pool. And then health probe, we have also configured this one. That is, it will keep on checking on port 80 on the backend VMs. So yeah, now if we just go to this IP address, we should be routed to either one of the VM. This is VMA. So we have this insights in the monitoring. If you just open this tab, you'll be able to see the flow of traffic and the health of the backend. If you just click on this VM, yeah, it shows it is healthy. So which is actually important for the traffic to be routed to this VM. If this is not healthy, then traffic won't be routed to this one. Next, let's tackle the internal load balancer. This is used for internal applications within your virtual network. Say for example, this is your virtual network. All right. And then there are, say for example, this is one subnet and this is another subnet. This is where you have, that you can say the DBVMs, right? And this is where you have a web server. It may be within one or two, doesn't matter. So whenever, this web application will be hosting via public load balancer. All right. So the traffic internet would be coming from here, and which we have seen already in the public load balancer part. Now the web server wants to interact with database server. So it cannot directly contact each one of them, because in this case multiple web servers may contact the same DB and cause throttling in the DB1 DB web server, right? So what internal load balancer does is, it is within the virtual network and a private IP address is assigned to it, and we'll call it internal load balancer. So all these web servers would talk to internal load balancer, and internal load balancer would distribute the traffic among these. So this is how the internal load balancer works. Let's head over to the Azure portal to configure an internal load balancer. So we're going to use the existing setup, that is, I've deleted the public load balancer and its IP address. And when it comes to the virtual machines that we have, I'm going to disassociate the public IP address because we do not want internet communication available on this. So I'm going to dissociate. Similarly, I'm going to disassociate the same thing on VMA, and I'm going to delete these because these are going to inflict cost to us. Now we have a VM that only has a private IP address and that is hosting a web server. I mean, in the example we have taken database server, but for this lecture we'll assume a web server, right? So it only has a private IP address and public IP address is not there. Similarly for the other VM. So let's go ahead and create an internal load balancer. So the same load balancer, you can just create one. Let's pick the same VNet and let's call it internal LB. And let's use it as internal. Internal can only be regional. And then if we go to front end configuration, let's give it a name. And you see, this is part of the virtual network subnet. We are going to use the default subnet. All right. So in the previous one, in the public load balancer, the front end IP is a public IP. Here in this case, the front end IP is a private IP within the VNet. And the backend pool, again, it should be part of the VNet only. As you can see, the virtual network is fixed over here. I can just name it backend pool, and then we can choose the IP configurations, that is the virtual machines that we want to attach to the backend. Let's just pick up both of them and let's save it. And next, inbound rules, we'll just add an inbound load balancing rule similar to what we have done in public load balancer. Let's give it a name. It'll be rule front end IP backend pool port. We know it's hosted on 80, so let's mark it as 80. Health probe, the same thing, we need to create one. Most of the configuration is similar, just that a small change would be there, that is the IP configuration and selecting what kind of load balancer do you want. Outbound rules, we do not want anything, so we'll ignore and just will review and create. It's going to take like a minute, and now it's done. So let's go to the resource and see the configuration. So yeah, if we go to the backend pool, we should see both the VMs. Yeah, and if you go to front-end IP configuration, this should have a private IP address within the subnet we have chosen. And then here we have specified the load balancing rule, and yeah, here is the health probe. And similarly, as what we have seen in public IP address, public load balancer, here in the internal load balancer as well, you can see the configuration, and as you can see, it's already marked as healthy, right? So now, to verify the usage of this one, we need to first go to the virtual network and see, like, what subnets are there. If there's only one subnet, let's create another subnet. Yeah, let's say, let's call it a web server subnet. We'll leave everything the default one. And now let's create a VM to access this load balancer, because this can only be accessed within the virtual network. So we need to have a virtual machine within the virtual network to verify the internal load balancer working, right? So let's go ahead and create one. We'll just create a sample, Ubuntu machine. I'm gonna name it test VM. I'll leave everything default. I'll use password authentication. And yeah, only SSH to allow, and I'll just review and create it. This will take a couple of minutes. I'll be back once it is done. So yeah, the deployment is now complete. Let's go to the resource. Now let's just copy the public IP address and SSH into the VM. We do not want to install anything else in this. We'll just take a look at the IP configurations once. We'll go to VM, and if we take a look at the address space or connected devices, basically we should be seeing three NICs that is assigned, three NICs and a load balancer. All right, so the test VM is having this IP address. Let's just curl into 4, 5 and then 6. So if you just take a look at curl 10.0.0.4, it's just, this is VMA, which is, the first one, that is VMA NIC. And then if we do the same thing with 5, that is VMB. And then the same thing if we do with 6, it's now routing the traffic between VMA and VMB. So let's understand a few practical examples of each one. So even if it's internal load balancer or public load balancer, the architecture of the front end IB, LB rule, backend pool would be the same thing. So let's just ignore that this is internal load balancer. Consider the same architecture for public load balancer. Imagine you have an e-commerce website with high traffic volume. A public load balancer helps distribute incoming requests across multiple web servers, ensuring no single server is overwhelmed. This improves both performance as well as availability. You would set up a public load balancer with front-end IP address via the internet and your web servers to the backend pool. Configure health probes to monitor service server health and create load balancing rules to define traffic distribution. This setup ensures that if one server goes down, the load balancer redirects traffic to the remaining healthy servers. Now, a scenario for internal microservices. Consider a microservices architecture where different services needs to communicate within a virtual network. An internal load balancer can distribute traffic between services like an API gateway and backend servers. For instance, an order processing service might need to communicate with an inventory service. By setting up an internal load balancer, you can ensure that traffic is balanced across multiple instances of the inventory service. This enhances reliability and allowing seamless scaling. You would configure an internal load balancer with a private IP address adding the relevant microservices to the backend pool. Set up the health probes to ensure each service instance is healthy and create rules to manage the internal traffic. Now let's have a few tips for the AZ-104 exam. To ace the AZ-104 exam, keep these points in mind. Front-end and back-end configuration, that is front-end IP address and back-end pools. Understand the differences and setup processes. Health probes, how to configure it and what's the use of it. Load balancing rules. Be clear on how to configure and when to use them. These concepts are not only crucial for the exam but also for real world cloud architecture. That's a wrap on Azure Load Balancers. By now, you should have a solid understanding of both public and internal load balancers, how to configure them, and when to use each type. This knowledge is not only crucial for the AZ-104 exam but also for the real world cloud architecture. Don't forget to like, subscribe, and hit the bell icon